All right, let's look at the topic today, system of equations, right? So systems of equations. And we're going to look at slightly more difficult question than normal, all right? Calculate is loud and round to three significant figures. All right, so the first question over here I've got is 2x plus y over 3 is equal to 10. And the second equation is x plus y over 2 equals 2, 5. All right, so we want to solve for x and y. What value of x and what value of y will satisfy both equations in this particular example here? Okay, give it a go. Let's see what you got. All right. Now, the first thing I'm going to do here is I need to equate the coefficients. Once I've got the coefficients equated over here, I can then use the process of elimination in order to subtract them from each other. Okay. So let's say I multiply this second equation by 2 across. That will recreate a new equation, which I can rewrite, let's say neatly, to get 2x plus, and the 2 will cancel out, leaving me with y equals to 10. The equation at the top remains exactly the same. So that's y over 3 equals to 10. Now I'm going to subtract these equations from each other because 2x minus 2x will eliminate. And that's what the word means, right? Eliminate means to remove completely. Now y over 3 minus y is like fractions. It's like saying 1 over 3 minus 1, which is the same as 3 over 3. 1 minus 3 is negative 2, right? So that's negative 2 over 3. So this would be negative 2y over 3. Subtracting top to bottom equals 0. So therefore, negative 2y equals 0. So therefore, y has to equal 0. So now I know if I put 0 into any one of the three equations, I can find x. I'm going to use this equation here because x is on its own and write it with y being 0. And I notice that this is going to become 0 because 0 divided by 2 is 0. Remember, y became 0. And so x equals 5. So therefore, we have the coordinate 5 and 0, where these two lines would intersect. Okay, or these two equations would intersect. All right, let's go to another one now. Suppose I've got x over 8 minus 40 plus y over 2 equals to 0. And the second equation I've got is x over 2 minus y over 12 minus 16 equals 0. I want to find the value of x and y, which will satisfy both of these equations, right? So I want you to find or solve for x and y for these two equations. All right, give it a go. Let's see what you got. Okay, again, the process of elimination would be ideally to get either the y's exactly the same or the x is exactly the same, in which case when I do subtract them, they'll eliminate. I can see this is x over 2, so if I make this into a 2, I can multiply this by 4. And that will produce an equation x over 2, which will ideally eliminate with the equation below. But if I multiply this term by 4, remember it's an equation, I have to multiply every single term by 4. Remember, we can use a calculator and round to 3 significant figures if we need to. This is going to be negative 160 plus 4 times y becomes 2y. 4y over 2 becomes 2y, and that's equal to 0. Now I have these two terms exactly the same. What I'm going to do now is I am going to subtract them from each other. Okay. All right. So now I've got these two equations. I'm going to eliminate them. That means these two are going to cancel. Over here, it would be ideal to keep these two in a straight line, which in this case means I have to take 2 and I have to subtract negative 12. And it'll become 2 plus 12, which is 2 and 12. And then this way over here, I've got 160, and I've got to subtract negative 16. So negative 160 plus 16 will become, so that's negative 150 plus 6, negative 144. All right, so that's going to get me negative 144. And on this side here, I'm going to end up with 2 minus 12, which is 2 plus 12. 2 times 12 is 24 plus 1 is actually 25 over 12. So this is just a bit of a calculation corner here. So that's going to get me, when I subtract, remember it's minus, which is plus, so it becomes 25 over 12. And just put a y in front. This is minus, it becomes a bigger minus. All right, but no, actually this is minus. So this becomes plus, which becomes a smaller minus. And now I'm going to move this across and get y. So remember, y belongs to the numerator over here. So this is going to be 25y over 12 equals 144. So I'm going to multiply 144 by 12. So 144 times 12 is equal to 1,728, which is equal to 25y. And I'm going to divide by 25 now on both sides, which means that I'm going to get that divided by 25, which is going to become 69.12. 69.12. So 3 significant figures will be 69.1, and that would be my y value. All I got to do now is substitute it into one of the equations to find it. All right, so what we're going to do now is substitute y, which is 69.1, into any one of the equations. Which equation we substitute it into doesn't matter. So let's go with this equation here, because x is dividing by 2. I'm going to write that equation at the bottom here. I got x over 2 minus 69.1 over 12 minus 16 equals 0. I'm going to bring that into a single digit and then move it across in one go. So on a calculator, I'm going to press the fraction button, and I'm going to go 69.1 over 12, and then I am going to subtract 16 from it. It can become negative 21.758. On the other side, becomes positive 21.8. And then I'm going to multiply that by 2. It's 43.6. So x is equal to 43.6 over there. Well, there we go. There's the coordinates. 43.6 and 69.1 will be the coordinate for this particular question. All right, double check my answer. Let me know if I'm correct or incorrect as well. We can then go through from there. Now, sometimes we get different kinds of functions. We have to remember that if I got y equals 2x plus 4, this is a straight line. If I got y equals to x squared minus 9, this is a parabola. And if I got y equals to x cubed minus 2x squared plus x minus 4, then this is a cubic function, which looks like that. If I got y equals to x, 2 over x plus 5, this is a hyperbola. All right, this is a hyperbola. And the hyperbola, in this case, would look like that. All right, where you have these two lines running, reflecting over this particular line, which is your hyperbola. We also have the exponential function, which is 2 to the power of x plus 3, let's just say hypothetically. In this case here, plus 3 implies that it's the asymptote over there, and 2 to the power of x plus 2 would be shifted up from the original. We also have the circle equation, which is y equals to x squared plus y squared, or x squared plus y squared equals to r squared. So x squared plus y squared equals r squared. And this is when the center is at 0, 0, 0. Then you get x minus a squared plus y minus b squared equals r squared, which is also a circle equation. And this is part of functions, not really anything we're going to do right now, but the center will be AB over here. What we're going to do from systems of equations, we're going to bring 2 or 3 of these equations together, and we're going to try and solve them simultaneously in the next example. And particularly, I want to look at the circle. So let's suppose my first equation is the circle, given as x squared plus y squared is equal to 16, okay? And this is basically a circle that goes through positive 4 and negative 4 on the y-axis with the center of 0, 0. And the 4 comes from the square root of 16, which is the radius, r squared. Now, this is my first equation. My second equation is the line y equals to 2x plus 1. And that will be some line that passes through the y-intercept of 1. And what we want to do is we want to find out what is that x and y value over there, and what is that x and y value over there, which is going to be solved simultaneously now. So that's equation number 1 and equation number 2. See if we can solve this one simultaneously first. All right, in this particular one, I'm going to use the method of substitution. And I'm going to substitute equation 2 into equation 1 because it gets squared. So I'm going to replace y in this case with 2x plus 1 and rewrite that equation. I now need to expand this bracket. So this is going to be x squared plus 4x squared plus 4x plus 1 equals 16. That becomes 5x squared plus 4x, and 1 minus 16 is negative 15. Now I have a equals to 5, I have b equals to 4, and I have c equals to negative 15. So therefore, I know that my x value can be found by taking minus b plus minus the square root of b squared minus 4ac divided by 2a using the quadratic formula. This will get me my x values, which I can then use to find my y values. Once I've got my x values, I'm going to substitute it into this equation because it's the easiest, it's ready to go to find y. So carefully, I can see my coefficient of x is 4. Don't forget this is negative 15, and this is 5. Let's see if these even exist. So minus b would be minus 4 plus minus. We have to have a positive square root for it to exist. So this is going to be 4 squared. According to my diagram, it definitely looks like it does, but let's have a look in calculation. Square root of negative is not allowed. Right, so there we go. A equals 5, C equals negative 15. So that's going to become positive, which is great. and then a over here is 5. This becomes minus 4 plus minus the square root of 16. 4 times 5 is 20. 20 times 150 is, so that's plus. 2 times 15 is 30. So 4 times 5 times 15 is going to get you 300. Okay, so this is going to be 316, which is not a nice number, but we're rounding to 3 significant figures. Let's get two values for x over here. I'm going to call it x1 and x2. Putting plus and minus on the calculator, each one separate subtraction button, minus 4 plus the square root of 316 divided by 10 comes to 1.38. And then minusing that becomes negative 2.18. All right, so I got x1 and I got x2. Now I need to substitute this into the original equation. So I'm going to sub in equation number 2. And I'm going to get y equals 2 times 1.38 plus 1. 2 times 1.38 plus 1 comes to 3.76. 2 times negative 2.18 plus 1 comes to negative 3.36. All right, and that's the two coordinates. From this one over here, I can see this is going to become the coordinate 1.38 and 3.76, which looks like this one over here, because it's somewhere over there, 1.38, 3.76 up. The next one is going to be negative 2.18 and negative 3.36, both being negatives, which makes sense because it's going to be over here and down, so it's going to be that point there. All right, and that would be the coordinates that I have there, respectively. All right, now you're going to go ahead and see if you can try circle equation now. The x squared plus y squared is equal to 9. And I got the equation y equals to 3x minus 1. Okay, and I want to solve this simultaneously. So give this one a go. Equation number 1, equation number 2. Find x and y that would fit in both equations and solve it simultaneously. All right, give it a go. Let's see what you get. All right, now step 1, I'm going to substitute 2 into 1. And there we go. And let's square this bracket out. And simplify this. 1 minus 9 is negative 8. 1 plus 9 is going to give you 10. So A equals 10, B equals negative 6, and C equals negative 8. X is equal to minus B plus minus the square root of B squared minus 4AC. I'm just going to write it down so remember when you substitute into it very carefully. So my X is going to equal negative 6 plus minus the square root of B squared, which is going to be negative 6 squared, minus 4 times 10 multiplied by C, which is negative 8. All divided by 2A, which is 2 times 10. This gets me two solutions, x1 and x2. Now I can simplify this first before I get those two solutions. This is going to be 6 Let's minus the square root. This is 36, and this is plus 4. 40 times 8 is 320, so that'll be 356 all over 20 from there. And I put this on a calculator. All right, so what I'm going to do is flip this on a calculator, and I've got 6 plus the square root of 356 divided by 20. It'll come to 1.24 x1, 1.24. And if I have to find x2, keep it on the calculator as well. Keep it on the calculator as well. If you do that, you don't have to print out the whole thing. So it's going to be negative x2, negative 0.643, the three significant figures. So therefore, I'm now going to substitute into equation 2, and I'm going to get y equals to 3 times 1.24 minus 1, and y equals to 3 times negative 0.643 minus 1. And that's going to give me my y value in each case. Okay. All right, so that's going to be 3 times 1.24 minus 1 comes to 2.72. And 3 times negative 0.643 minus 1 comes to negative 2.93. Please double check my solution if I got the correct one as well, so I didn't make any errors. 1.24 and 2.72, as well as negative 0.643 and negative 2.92. That's where the straight line will go through this particular equation.